Alrighty, good morning everyone. I decided instead of teaching live, it might be easier on some days to do a pre-recorded video. Uh, that way when you're on for the entire period, if you have questions, you can say, hey, I had a question on this part, and I can pull up the notes and go through it with you. So, the very start for this, I'm going to try to keep these videos like I would in class. I'll give you bell work. I'll tell you a time to pause the video and try problems on your own before you keep playing the video. So this is the bell work part, simplifying radicals. This is something you absolutely need to know how to do before we go into the quadratic formula. Now, with simplifying radicals, if you're used to doing the factor tree method where it breaks down into a bunch of little branches, I'm going to say don't do that because it takes an exceeding amount of time when there's another method that is a lot simpler, which is the perfect square method of simplifying a radical. If you haven't been taught that, the way it goes is that you just separate the radical into the largest perfect square that divides into it, and then the quotient. So we know 44 can be divided by 4 with a remainder of 11. This way you can immediately see what you can simplify outside the radical and what stays inside the radical. Of course, we know our -1 pops out as an I. So I can quickly say that the root of -44 is equal to 2I root 11. The root of 4 became 2, the -1 became I, the 11 stayed inside. Let's keep that going. -80, the highest perfect square that divides into it. While 4 does divide into it, that becomes 4 and 20, and 20 can be simplified further. The highest perfect square that can divide into 80, pull out my -1, is 16, leaving behind a remainder of 5. So my answer becomes 4I root 5. The root of 16 became 4, the root of -1 becomes I, and the 5 stays inside. The root of -21, that only breaks into 3 and 7, so we can't really simplify the number inside, but we do have to pull out that -1. So 21 stays as it is. We have I root 21. I know Edgenuity may have taught you to put the I behind the square root. That is a disgusting notation. Please don't do that because it looks like the I can be inside the root sometimes. 45 breaks into the root of 9 times the root of 5. So to simplify that, the root of 9 is 3 with the root 5 left behind. So my advice when you get these numbers, just start dividing away. When I got to 80, my first instinct was, hey, let's try dividing by 4, but I got 20 left over. And I said, okay, well, let's see if a higher perfect square works. 9 didn't work, so I tried 16, and there we go. I was just left with 5. Okay. To go over different parts of the quadratic formula, the discriminant, not discriminate, discriminant, b squared minus 4ac. The reason it's called that is because we're prejudging what the solutions of the quadratic formula will be. If that part underneath the square roots, this part here, if that part is greater than 0, we can take the square root. We will have 2 real solutions. If this part is equal to 0, well, the root of 0 is just 0. We're only going to have 1 solution. That pops up from time to time. If it's less than 0, that means the number under the root is going to be negative, and according to what we just did here, we're going to have some i's, which means we're going to have some imaginary or complex, sometimes tests will call them non-real solutions. And then we have our quadratic formula. X equals -b plus or minus the root of b squared minus 4ac all over 2a. This is used to solve for x-intercepts of a quadratic equation, which is an x squared equation that's a parabola. We're solving to see when does it hit the x-axis? Does it hit the x-axis? If it never hits the x-axis, that's when we have our imaginary solutions. Yeah, pretty much that. Sometimes it might only hit it once. These are also called zeros or roots. So let's just jump into this. Here's an example problem. 3x squared minus 4x minus 9 equals 0. My first step is always just plugging in the values. So I actually need to fix this. Oops, no, go away, Steam. -4. And I'm actually glad I made that mistake so I can point that out to you. The first step is negative b. So if b is already negative, well, guess what? That b is going to become positive. Step 2, simplify the discriminant. Just simplify what's inside. Now, I am going to make that 4 outside positive, but plus or minus. Let's see here. Negative 4 squared is 16. And negative 4 times 3 times negative 9 gets me a positive 108. So underneath that square root, I'm going to have 108 plus 16, which is 124. I know that's not a perfect square, so I'm going to have to simplify this. Now, let's see what we can get. 4 plus or minus 124 divided by 4 gets me 31. So I can break this into the root of 4 times the root of 31. Now, 31 is prime, so I cannot divide anything else into it, which means 4 is the highest perfect square that divides into it. Take the root of 4, the 31 stays inside, that's all over 6. Now, we are not done with this, because outside the radical, I have a 4, I have a 2, I have a 6. The way I would explain this is pretend I gave you 4 plus 2x over 6. Now, I'm going to erase this in a second, but the idea is that you would know that you'd have to reduce all these by 2, hopefully. Divide by 2, divide by 2, divide by 2. That's simplifying a complex fraction. This is the same thing. You never want to simplify something in the root because it's its own thing. Just like you wouldn't mess with x with a bunch of even numbers outside. So we are going to have to reduce this as my final step. So x equals, divide everything by 2, 2 plus or minus. I am not going to put 1x or 1 root 31. You have to know that there's an invisible 1 there. Over 3. We can't simplify further. I don't want any decimals for this. I don't want you to find the root of 31 in your calculator and do plus or minus with the 2. No, just leave it as it is. It's fine as a complex solution. So that is our final answer for this. All right. I'm going to do a couple examples for this, usually 2 or 3, the more the better. If you feel like you have the hang of the stuff that we're doing, this is going to be a video, so you fast forward as much as you want, or you pause it as much as you want and go back and listen to what I'm saying. But if you'll notice, I'm going with this with the hope that you guys are comfortable with simplifying your radicals and watching your negative signs. Example 2, x equals negative b plus or minus the square root of b squared minus 4. A is 1, c is 27. I know some people had a song that went to the tune of Pop Goes the Weasel. Nah, when I learned it, just like, hey, go ahead and memorize this giant thing. All over 2a, 2 times 1. All right, first step is just going to be to simplify the discriminant. Negative 9 squared is 81. That's going to be a minus because that's negative 4 times 1 times 27. So let's see what we get. Negative 4 times 1 times 27. 108. So let's see what we have. 9 plus or minus the root of 81 minus 108 gets us negative 27 over 2. And I have to break down that root. So 27 divided by 9. That breaks into the root of 9 times the root of 3. I'm also going to have the root of negative 1. So 9 plus or minus. On the outside, I've got 3i. That's the root of 9 and the root of negative 1. And that other root of 3 stays inside. All over 2. Okay, and that's it for that one. I can't simplify because on the bottom is a 2. If it was a 3, I could do something, but not with a 2. All right, my last example. Your goal when solving for x with the quadratic formula is that everything needs to be on one side. So start by pulling your terms to the same side. And please keep your x squared positive. It will make your life easier. 6x squared minus 7x minus 20 equals 0. Okay. I've got my A, my B, and my C. Please make sure to include the signs in those. So x equals negative b plus or minus the root of b squared minus 4ac. Hopefully in a bit you'll be able to do the quadratic formula like the back of your hand. 2 times 6. All right. 7 times 7 is 49. That's going to be a plus because we got the negative times negative. 4 times 6 times 20. 480. That's a big one. 7 minus plus 49. 529. Is that? It is. Nice. That's a perfect square. Always check that first. All right, so we can actually get some regular answers for this. 7 plus or minus the root of 529 is 23 over 12. Now here's how I write these. I got 7 plus 23 over 12, and I got 7 minus 23 over 12. So up here I have 30 over 12. That does not divide evenly, so I have to reduce it. You can reduce by 2 and then by 3. I prefer just reducing by the largest number that can divide into both. That's going to be 6. Don't let fractions freak you out. They're just two numbers on top of each other. So one of my values is 5/2. The other one, let's see what we get. 7 minus 23 should be negative 16, yes. Over 12. Simplify that. Those can both be divided by 4. Negative 4 over 3. Now, I don't want you to leave these like this. Don't write x equals 5/2 and x equals 4/3. These are x-intercepts. This is 5/2, 0, and negative 4/3, 0. Just like when you were factoring. There we go. Well, I suppose we kept it as x equals when we factors, but that's okay. Okay, so there are some regular answers, more or less. Fractions are fine. Don't fear the fractions. They're just two numbers on top of each other. Okay, now, this is a point in the video. I know this is kind of long. I want to go over a bunch of examples where I'm going to say, try these by yourself. So I'm going to pause for about 5 seconds to give you time to pause the video. Try these two, and I'm going to continue writing down my answers. That way, when you unpause the video, you can go through and check your work. Now, I'm not going to make any commentary on these. I'm just going to work on these problems. So make sure you pause the video. Don't just watch me do it. Try it yourself first. Okay, 36 minus 24. That's a little too close. Let's space that out. Okay. And again, when you reach complex fractions like these, don't worry about crunching it down to decimals. This is how I want you to enter your answer, which is why I showed you how to use the math quill tool. All right, now the bell's about to ring on my end, so let me see if I can Get this going. Plus 7 to both sides. Time crunch. Let's do this. Whenever you have a negative in here, make sure to put in parentheses. That way you remember that when you square a negative, it becomes positive. Okay. 4, 8, 12, 12 times 7. Too early for this. 12 times 7, 84. Minus 84. Looks like we're going to have some imaginary answers. And again, that's the discriminant part. I knew the inside's negative, so I know I'm going to have some imaginary numbers. 6. Let's see, 80. I believe we just did that one on top. Yeah, we did. 80 breaks into 16. And 5. How convenient. So 4i root 5 underneath. We got our 6, just like the last one. We need to simplify. So 1 plus or minus 2i root 5 over 3. And that was from me dividing them all by 2, because this is a fraction we can simplify. And that is your quadratic formula. Your homework is right here. I'll post the notes to Canvas as well. I'll always try to do that. Sometimes these videos will be a little long. After all, I am trying to give you the classroom experience. But that's all I have. Let me know if you have any questions.